Good morning, class. Today's lesson 2.2 for Tech Math. We're talking about subsets. In 2.1, we discussed different types of sets, and there's a little review of that 2.1. You can read this, pause the slide, whatever you need, but these are the main pieces here. Make sure you review and understand what these symbols mean, as well as how we can compare these different sets. As we move forward into 2.2 here, look at actual subsets. We're talking about groupings. And so if you have a subset, let's say students in tech math, you could actually break that into smaller groups. Like our class could be the set, and subsets within our class could be the girls in the class, the boys in the class, the players in the class who play basketball, the people with blue eyes that are in the class. So that's how we talk about subsets. Within a group, we'll have subsets of those sets. I guess it kind of makes sense. Anyways, let's move on. So a subset, here's how we kind of read and state these pieces. Set A is a subset of B if and only if all the elements of set A are also in set B. And we write this using this signal here, this like kind of squashed C with a line under it. That means subset. So when you see that, what we're looking at is whether A is a subset of B. So example here could be the girls in our tech class are a subset of the tech class. Let's look at some examples. Determine whether set A is a subset of B. And I'm going to go through each of these individually, but lettuce, tomato, and cucumber, is that a subset of tomato, cheese, lettuce, and cucumber? Second example, 2, 3, 4, 5, is that a subset of 2, 3? And the third example, banana, lemon, and papaya, is that a subset of yellow fruits? Let's take a look at them. So in the first one, determine whether set A is a subset of set B. We can see here in set A, lettuce, tomato, cucumber are all included in set B. And so this would actually be a subset. And we'd write A is a subset of set B. So set A is a subset of set B. The next example, determine whether set A is a subset of set B. Well, when we look here, 2, 2, 3, 3. Uh-oh, we're missing these two. So this not going to be a subset. How do we write it? Set A is not a subset of set B. Put the little slash through the subset mark. Third example here for this one, bananas, lemon, and papaya. Are these all yellow fruits? I should maybe use yellow instead, huh? Yellow fruits. Well, bananas are yellow, lemons are yellow, papayas are yellow. So yeah, this would be a factual subset. Yes, set A is a subset of set B. So when we talk subsets, everything in A has to be part of B to be called a subset. Well, within that, we can actually go even further and look at what we call proper subsets. So a proper subset is if set A is a proper subset, if and only if all the elements of set A are elements of set B and set A is not equal to set B. So this means that set B must contain at least one element not found in set A. That's what we call a proper, and you can see the symbol down here. It's got this little, this is our symbol for a proper subset as compared to just the symbol for subset. Okay, well, let's continue here. So as we look at some examples, first in here, determine whether set A is a proper subset of set B. Proper subsets. You can see here in set A, Ford, Kia, Jeep. Okay. Well, we've got them. So what does that mean? Well, as we're seeing here, this is a proper subset because it satisfies the idea that we do have the Ford, the Kia, and the Jeep. So all of A is found in B, And B has a couple of other things. Let me try a different color. B has Chevrolet and Honda in addition to. So that would be, or mean it's a proper subset. Okay, determine whether set A is a proper subset of set B. We're looking at set A. We've got the A, we've got a B, we've got a C, we've got a D. Uh-oh. They look like they're the same. What does that mean? Well, that means that they're the same. Set A is equal to set B. So set A is not a proper subset of set B. However, A is a subset of B. So that's the difference here. We're talking proper subset versus just a subset. So it's a proper subset when it's got, like, if this did not have a D here, then we could call this a proper subset because it's got all the stuff that you find in B, but B also has one more thing or an additional thing or things. Okay, so if you're not sure, go back, check it over, reread the section again, obviously, if you need more help. Let's do a couple more here. To look back at lesson 2.1, we talked about elements versus subsets. And when we talked about those elements versus subsets, we have to kind of figure this out. So remember, the element symbol is this little E looking symbol. And the first one here, determine whether the following are true or false. So this is kind of like on your homework. On your homework, you're going to have to determine true or false. And then additionally, you have to tell why. Why? Wow. Nice. Okay, so you're telling why. First one. E, element of 3, 4, 5. That is true because E is a member of the set 3, 4, 5. Remember the brackets here, these braces mean set. So this is true. The next one. The set 3 is an element of the set 3, 4, 5. Nope, that's not going to work out because the set 3 is a set and separate from the set 3, 4, 5. So when you see the brackets, you're thinking of this as the set of the number 3. And this is the set of the numbers 3, 4, 5. All right, moving on to the third one here. 3 is a subset of the set 3, 4, 5. That's actually going to be false. 3 is not in braces. And so without having braces around it, it's not a set. It can't be a set. If it's not a set, it can't be a subset. So 3 without the braces is not a set. So it's not going to be a subset. The fourth example, 3 with braces is a subset of the set 3, 4, 5. That is true. 3 is an element of 3, 4, 5. And then last but not least, let me move my little camera thing here. The empty set, that's what that means, is a subset of every set, or 3, 4, 5. Well, it is because it's a null, the null set or the empty set. When you see the braces with nothing inside, we call that the null set, and that is a subset of every set. So even though you got 3, 4, 5, the null set or the empty set is going to be part of that. Okay. All right. So, sorry about that. So hopefully, that helped a little bit. Real quick review here on 2.1 again. We kind of went through these. Set A is equal to set B. A equals B. If and only if set A and B contain the same elements, exactly the same. The cardinal number of set A, symbolized by NA, is the number of elements in a set. This is all from 2.1. If set A is equivalent to set B, if and only if the cardinal number of A is equal to the cardinal number of B. And the set that contains no element is called the empty set or the null set. And we symbolize this by the empty set, so just braces, or the null set, which is this 0 with a slash through it. The universal set is symbolized by a U. It is a set that contains all elements for any specific discussion. So those are reviews from 2.1. 2.2, here's what we're adding to it. So those of you who are keeping notes and checking your notes, add this to your notes. Set A is a subset of set B, which is symbolized by A subset B, if and only if all the elements of set A are also elements of set B. Set A is a proper subset of set B, symbolized by proper subset of B, if and only if all the elements of set A are elements of set B and set A is not equal to set B. That is, set B must contain at least one element that is not in set A. And then third point here, the number of distinct subsets is a finite set of finite set A is 2 to the power of n, where n is the number of elements in the set. So as you go through your reading and reading through this lesson 2.2, when you get to the part about the Wendy's burger, I thought that was kind of cool. Like if you're eating at Wendy's and you can get a burger with whatever stuff you want on it, like ketchup and cheese and lettuce and mayo and mustard and pickles and onions and tomatoes, how many variations can you make? Well, if there's 8 different things you can put on it, 2 to the power of 8 is how many variations. So you could have 256 different kinds of burgers at Wendy's. That's kind of wild. It's kind of wild. Anyways, on to your homework. For the homework, we're looking at pages 49 to 50, and you're going to do 8 to 54 even. So 49 to 50, 8 to 54 even. Real quick, as we're moving forward in our progression here, to get full credit for numbers 8 to 24, you're going to state whether they're true or false, and then you're going to explain why you chose true or false. 26 to 32, use proper symbols to explain why you chose your answers. Number 34, 36, explain why you made the selection you did. And number 38 to 54, explain why you made the choices in your responses. Those are more of word problem type problems. So make sure you explain the reasoning behind it. Anybody can just open the book or go to the back and open the PDF and literally copy down what's there. Anybody can. In fact, I'm sure some of you have, unfortunately. It's not my first rodeo, and I can tell when I'm seeing copying. So going forth, you will not receive full credit if I think you're just copying it down from the PDF. So you need to explain the reason why you chose what you chose. All right. Best of luck on this assignment, and we'll talk to you real soon.